Look at how you can find the area of a triangle, specifically when it's oblique, just when it's not a right triangle, maybe when it's an acute or an obtuse triangle. And so we've got an equation that we can do with that. If you're given two sides and an included angle, so it's a side angle side relationship, then you can find the area of the triangle by taking 1/2, and you would take the two sides, multiply them together, and then take the sine of the included angle. So this is the included angle. So if you've got a triangle here, and we had 5, let's say 10, and the angle in here is 53 degrees. No matter which equation you're using, you're going to take 1/2, 5 times the 10, and then times the sine of the angle that you're given, 53. So you can ignore the AB, AC, BC parts and things like that, and just focus more on the measures that you're given. So the measures you always will do multiply the sides together, and then it's sine of the included angle. All right, here we go. Find the area of a triangle in which C is 143 degrees. A is 7, let's just say that's 7, and B is 18. All right, so there is a rough drawing of that, but to find the area, you would take area is 1/2, the two sides, 7 times 18, multiply by the sine of the included angle of 143 degrees. And then now you're just going to go ahead and use your calculator. You should still be in degree mode. And so area of this triangle, calculate, you get 37.9 square meters. Make sure you label your meters here, it's the identification, and square units because you're finding area. All right, so there's that simple formula that you can use, and we do have other formulas, but as long as you can find a side angle side relationship, side angle side, then you can use this formula. All right, let's see what we have here for example 7. It says 2 Fire Ranger tires lie on the east and west line are 5 miles apart. I think this is supposed to be towers. 2 Fire Ranger towers lie on the east-west line and are 5 miles apart. There is a fire with a bearing of north 27 degrees east from Tower 1 and north 32 degrees west from Tower 2. How far is the fire from Tower 1? All right, well, let's first do the towers. They're 5 miles apart. It says there is a fire with a bearing of northeast 27 degrees from Tower 1. So here's Tower 1. And if the fire is northeast, then you do the north line, remembering you go east, and then that angle is on the outside here, 27 degrees. This means 27 degrees east of north. And then it says the fire is 32 degrees west of north from Tower 2. So here's Tower 2. And if you go west of north, then that angle is here again on the outside, west of the north line, 32 degrees. How far is the fire from Tower 1? Here's my fire, and here's Tower 1. So I need to find this measurement here, x. What I can do is I can set up my, my angles inside my triangle. I know that since this is a north and east-west line, that would be a right angle. So the complementary angle to 27 is 63 degrees. And the complementary to 32 degrees is 58. Okay, that leaves the last angle on top. If you subtract them from 180, this would be 59 degrees. You're going to go ahead and use the law of sines. 5 over the sine of 59 equals x over the sine of 58. Cross multiply, divide, you'll get your x value, and it is 4.95 miles. And there you have it. All right, there are times when we do not have enough information to use the law of sines, and so in that case what we have is the law of cosines. Given two sides and the included angle, so you would be given a side angle side relationship, two sides included angle, or side side side. You see the law of sines, we used side side angle was a relationship, and angle side, or angle side angle. Okay, so in this case here we have to know two sides, included angle, or three sides, and then you can use the law of cosines to solve. Here are the formulas, and again you can ignore the the A's, the B's, and the C's somewhat. You've got the side squared opposite angle cosine there, and then the rest of the sides are included in the formula here. So take a minute here and at least write down the formulas. You can pause the video to do that if you need to. We do have some rules that we want to follow when we're doing the law of cosines. Number one is that you use the law of cosines when the sine ratio does not exist. And then you can finish using the law of sines. If you're given three sides, you want to find the largest angle first. This will rule out any problems with the law of sines. The law of sines will never give you an obtuse angle, so if you're really finding an obtuse angle, you wouldn't know that. You would actually get the acute version of it from quadrant 1. All right, here's our first example. Given a triangle with C being 111 degrees, let's go C 111, and A is 27. Let's go ahead and do this A up here, 27, and B, let's call this angle B, is 18. Find the remaining side and angles. All right, well, we've got a side angle side relationship. The first thing that I will need to find is I will need to figure out little c. So we do c squared equals, and in the formula you square the other two sides, 18 squared plus 27 squared. Then it's minus 2 times both sides, 18 and 27, times the cosine of the included angle 111, the angle opposite of what we're trying to find. So we've got c squared equals, if you square your 18, we would get and 27 squared is 729 minus, and 2 times 18 times 27 is 972. Cosine of 111. And so really what you can do here is you can just type all of this in and get what c squared is equivalent to. So c squared should equal 1401.334. So 1401.334, and then so take the square root of it. C would equal approximately 37.43. All right, what we need to find now are the angles. If I find my angles, I can now use the law of sines, because I can use the 37.43 over the sine of the opposite angle 111 equals 18 over the sine of angle B. So you would solve for angle B here, and we'll solve for C. So once you cross multiply and divide here and find B, your angle B is going to equal 26.7 degrees. Remember, you have to use the inverse sign to find your angle, inverse sign. So 26.7. And to find the last angle, you are able to subtract them from 180. So your last angle would be 42.3 degrees, and that would be angle A. And there you have it. So here's solving the equation, or solving this triangle here using our law of cosines equation. You do the law of cosines first, right here, and then second, you do the law of sines, and then third, you do 180 minus the angles that we had. All right, let's take a look at our next problem. Given a triangle with sides 5, 8, and 7. Okay. 5, 8, and 7. Find all three angles. Okay, let's go ahead and give these angles an A here, a B, and a C. It doesn't really matter where I put those. One of the recommendations is that we find the largest angle, because if it's obtuse, then you get that out of the way. So my largest angle would be angle A. So you start off with 8 squared using the formula for the law of cosines equals 5 squared plus 7 squared minus 2 times 5 times 7 cosine of the angle that we're trying to find. So here's how you solve this. You have 64 equals 25 plus 49 minus 70 cosine of A. You have to solve this as if you're isolating cosine A. So it's 64 equals 25 plus 49 is 74. And if you subtract 74, you get negative 10 equals negative 70 cosine of A. Divide by negative 70. And you get 0.14287 equals cosine of A. Now you would do inverse cosine of that decimal, and you get the angle to be equal to 81.8 degrees. So angle A equals 81.8 degrees. All right, so I found my largest angle first. What you do is you have to go through the whole process of trying to isolate this cosine of A. So you'd have to do your order of operations and inverse operations to isolate it. Now you're going to use the law of sines. 8 over the sine of 81.8 equals 5 over the sine of C, and we can find C. And when you solve that, you should get that C is equal to 38.2 degrees. And then, of course, to find A, you can subtract the two angles that you get, 81.8 and 38.2 from 180, and that leaves us with 60 degrees. That's it. All right, this is going to conclude the video on the law of cosines. Our next video will include some application problems.